weight for all the integers, for all the fractional part. Fractional part is having a power minus j, mean 1 by something, 1 by 10, 1 by 3, 1 by 4 as per the base. So whereas integer is having a multiple 10 to power 2, 10 to power 3. So that is a each digit of the base is known as the face value, whereas the place value is given as a weight. Now we have discussed the arithmetic operations for the binary. So when we are talking about the binary, then before binary, here we have discussed the addition. So this is the minimum and maximum value of any base with a digit. Be careful. You have to use the smallest digit of that base and the largest digit of the base. And base you have to represent as a subscript of the bracket. And then you can represent r power n minus 1 as a decimal number. R mean base, n mean the number of digits you are going to combine. Here in this case, 2 digits are combined. So here is 2 power 2, 3 power 2, 4 power 2, and we are using the largest digits. So smallest digit will give you the smallest number. When you are combining the largest digit, then that will give you the maximum number. Maximum number is equivalent to this one. So here is 4. So 2 power 4. Here is 4. 3 power 4, 4 power 4, or 16 power 4, 10 to power 4. Now you can correlate with your base 10. Then conversion of r number to the decimal base, we have to segregate the digits. When we have to segregate the digits, we have to divide by the base for the integer value and go on collecting the remainder. That is your segregated digit, separated digit. But when we are using the fractional part, then we have to multiply by base, and then you can collect the integer part, that is your segregated value. So that yesterday we have discussed, and there is conversion is there when we are dealing with the fractional part. So we cannot stop till your multiple can become 0. Okay, so the fraction part may or may not be 0, then you can go up to your desired accuracy or the repetition of digits occurs. Now we will discuss the arithmetic on the base R. How we can do the arithmetic? Basically, we have to follow the addition or subtraction or multiplication or division as per the decimal values, decimal system. You know, multiplication and the division depends on the arithmetic addition or arithmetic subtraction. So main aim is how we can get the arithmetic operation for particularly addition and subtraction. So what we do, we have to perform the subtraction as such. And before that, you have to think about, for example, here digit 5 is there. 5 can be represented in the form of base 2, that is a binary number. That is 2 power 0, 2 power 1, 2 power 2, 4 plus 1. It is a 5 as 10. So this is 3. In the base 3, it is 2 plus 3 power 1, 3 plus 2, 5. Here 1, 1 is a 5. So 1, 0 in the base of the 5, that is your digit 0, and 5 power 0 is 1, 5 power 1 is 1. So this is the representation. One decimal number can be represented in any base. Okay, so that is very much important to recognize. So, for example, in all these numbers, you can find system, for a 3 system, base 3, for a base 4, for a base 5. Similarly for 6, 7, 8, 9 and hexadecimal. 1 is a valid number. So we can decide here for a decimal digit equivalent base. 2 value is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it can be represented in 4 binary digits. 9 can be represented with the help of 4 binary digits. 7 can be represented with the help of minimum 3 binary digits. So you can, here is 0, 1, 2, 3, so on. Similarly in the base 2, 0, 1, 2, 1, 0 here, that is 3, 1, 1, 3 plus 1, 3 plus 2, here is 6, 6 plus 0, 6 plus 1, 6 plus 2, because weight value of the second digit is 6. Here is 9, 9 plus 0 plus 0. So be careful here, 2 is coming as a valid digit number. But you will not find any, in the base 3, you cannot find 3. You can find only up to 2, that is base minus 1. Here is base 4. You can represent it as 0, 1, 2, 3. So this is similar to your decimal number. For base 3 up to 2, it is similar to the decimal number. Okay, 5 base up to 4, it is similar to the 5, 6 base 5, 7 base 6, 8 base 7, and 9 base up to 8. Okay, so it means some digits are equivalent to your decimal, and when we have to represent other number in that base, then you can find accordingly the conversion. So here is 1, 0. 1, 0 means the first value is 1, weight value is 1, second is having 5, 5 plus 0, 5 plus 1, 5 plus 2, 5 plus 3, 5 plus 4. So here is 6 plus 0, 6 plus 1, 6 plus 2, 6 plus 3, 7 plus 0, 7 plus 1, 7 plus 2. So 7 in decimal can be represented 1, 0 in base 7. So this is the important, because here 7 can be represented by the 2 digits. So 1 is 0 and 1 is considered as a carry. So if you are thinking about the 1 digit, so you are considering the second digit, that will be treated as a carry. Okay, so this is the main concept here for the addition. So base R addition and subtraction operations are performed in a manner similar to decimal arithmetic. One thing only. After the arithmetic operation, decimal number is obtained. The decimal number need to be converted into the desired base R by subtracting the base value R from each decimal digit. In result, hello, मैं थोड़ा ठहर के भी फोन करता हूँ. So sorry, here is and R. So what we have to do, if I am having any decimal number, base value, first I will convert it into the decimal, perform the operation, and the result, again you have to obtain a digit. Same base value, same digit value you can get. So this is your main consideration here. So if I am considering the addition, so first you get a base R value to the decimal, perform the addition, result you can convert each digit into the base R by subtracting base R value. For example, here is your number 0 and 0 both are added, there will be no carry. This carryover is taken. This is your carryover. So this is carryover. So if here is 0 and 1, no carry. If it is 0, 2, because 2 is a valid number of a base 3. So 0 and 2, 0. But if here is 1 and 1, there is no carry. But when I am performing 1 plus 2, 1 plus 2 you will get. 1 is converted into the decimal because that is the same value. 2 is converted into the decimal number, that is the same value. But no, 1 and 2 as a decimal number. You will get a 3. 3 is not a valid number valid digit of base 3. Then you have to convert it into the base 3. How you will convert? 3, subtract 3 from the sum value. Sum value is 3, 3 minus 3 is 0. It means one time you have subtracted, so 1 will be the carry. How many times you have subtracted? You can get so many times the carry. So you can understand again, 1 is a decimal is equivalent to 2 is equivalent to decimal, 1 plus 2 is 3. 3 digit is not a valid digit of base 3. Then you subtract 3 minus 3, you will get 0. One time you have subtracted, so you will get a 1 as carry. So similarly here 2 plus 2, 4. 4 is not a valid number in base 3. So then what you will do? 4 minus 3, you will get 1. And how many times you have subtracted? 1 time, that will be your carry. That will be your carry. So you will get here 1 carry. So this is the procedure how you will get. So another examples are there. Here if I am considering base number, 3 plus 3 is added. 3 plus 3 is 6. 6 is not a valid digit of the base 4. Because valid, how many are the valid digit of the base 4? How many digits are the valid digits of the base 4? Those are 2, 1, 2 and 3. 4 is not a valid digit of the base 4. R minus 1, 4 minus 1. That is the maximum digit in the distinct digit values. Okay? So 0, 1, 2, 3 is your basic digit. So 3 plus 3 is 6. 6 is not number. So you have to subtract 4. 6 minus 4 is 2 and 1 will be the carry. How many times you have subtracted? 1 time. So 1 will be a carry. So here is base 5. 3 plus 5, 7. 7 minus 5, 2. Why we are subtracting 5? Because I have to convert decimal number into the base 5. So 1 will be the carry. Here 5 plus 2, base 6. So I have to subtract 6 here. 7 minus 6, 1. And 1 will be the carry. 6 and 6, 12. 12 minus 7, 5. And 1 carry. So 7 plus 6, 13. 8. Basically 7 plus 6, 13. 13 is represented by 2 digits. Okay? In decimal. So you have to convert it into the base 8. 13 minus 8, 5. 1 will be the carry. Okay, 9 plus 9, 8. 8. So, and 1 carry. So this is your 9 plus 9, 8 and 1 carry. You are carrying here. So this is the reason. Because 18 is your 2-digit number. So you are getting the. So here is the rule. Addition in base R number system is performed in 2 ways. Add carry to the organ. So here first number is known as the organ. Second number is known as the addend. You will get the sum and the carry over. Carry will always flow to the next digit. So addition in base R. So why I am giving you each step? Because when you are going to design your digital circuits, so these things are required. How many flip-flops are required? How many registers are required? So those are to be decided with the number of digits. So why I am stressing on each digit value? So add carry to the organ to get a partial sum and addend to the partial sum to get the final sum. Carry over in previous step must be taken care. So this is the start operation from the least significant digit. Consider 0 as a previous carry for the first digit. Numbers of digits of organ and added must be the same. So this is very important point. If not, complete by filling 0 to the most significant side. To the most significant side. Because if I am saying 0, 1, no problem. But 1, 0, place value is changed. So you have to add the zeros in such a manner so there should not be any change in the number. So 2 things you have to consider. Always start the operation from the least significant digit, and for the first digit, previous carry is 0. Augment and addend digits must be the same. And if these are not same, you can get it. Now here is your two values, 1, 0, 2-digit number. Here is, 1, 5 and 2, 6. Both are added. What is the problem? So this is your previous carry for the first digit. This is the least significant value. So this is the least significant value. 5. 5 is the least significant value. And 6 is your again least significant of number. So you have to start your addition from the least significant side. This is your previous carry is always 0. Now 5 is a valid number of the decimal number. 5 and 6, 11. Subtract 10. So here is 1 carry and 1 is your value after the subtraction of 10. So now here you have to add the carry with the augment. So you will get 2. This result is added with the added. 2 plus 2 is 4, which is less than 9. Less than or equal to 9. Because 0 to 9 are the distinct digits of the decimal numbers. Right? So here if I am considering the base 3. So here is one number. So this is your first digit. Least significant digit of the augment. This is the least significant digit of the added. Previous carry you have to consider 0. So 0 plus 2, 2. 2 is, here is the problem. Here is 2 value should be there. Here is 2. 2 plus 2, now 4. 4 minus 3, 1 and 1 carry. 1 plus 2. 4. 4 minus 3, 1 and there will be 1 carry. Be careful, your base value 3 is having a 3 distinct digits 0, 1 and 2 only. If you are getting any number more than 2, you have to subtract 3. Okay? So this is the consideration. Similarly here, so first you know the rule. What is your base 4? Base 4 value you are having how many distinct digits? 4. What are those? 0, 1, 2 and 3. If you are having any value more than 3, you have to convert it into the base 4 by subtracting 4 only. Okay, so here is 3 plus 2, 5. 5 is more than 4. Subtract 4 is 1 and 1 carry. 1 plus 3, 4. 4 plus 2, 6. 6 is more than 4. More than 3. Then you have to subtract 4. So here is 4 and 1 carry. 1 plus 0, 1. 0 plus 1. 1 plus 1, 2. 2 is less than 3. So there is no need to subtract the value because 2 is a valid digit of a base 4. So this is the way how we can perform the addition. Here is a base 6. 6 is 3 plus 2, 5. So how many distinct digits in base 6? 0, 1, 2, 3, 4 and 5. Total number will be 6. Starting from 0 to 6 minus 5. 6 minus 1, 5. So then 3 plus 2, 5. 5 is a valid number of base 6. No need to convert. Plus 2 plus 4 is 6. 6 there is need to convert. So it is more than 5. So subtract 6. 6 minus 6, 0 and 1 carry, 1 carry. So this is the way. Only the difference is if you are you have to perform the addition in decimal. If your result is giving you a digit or number of digits which are not the distinct digits of that base, subtract that base value. Okay, so this is the problem. So similarly here you can perform the subtraction by the same way. But here the problem is you have to, again I am considering the base 3. So 0 minus 0, 0, no borrow. So manuend, subtrahend and difference and it is a borrow. instead of carry from the next digit, you are getting a borrow. It means a minus value. So manuand and subtrahend both are subtracted. Subtrahend is subtracted from the manuand. You will get the difference. So always this borrow is subtracted from the manuand, then subtrahend is subtracted from the manuand, and then you get the difference. So here is 0 minus 0, 0. 1 minus 1, 0. No borrow. 2 minus 2, 0. No borrow. But here is 0. 0 is less than manuand is less than the subtrahend. There is need of the borrow. So here is 1 borrow. Here it is not 10. Be careful. It is not 10. It is a base 3 value 3. You are getting a borrow as a 3. And you have to represent in that base. 1 0 is a 3 value in decimal, and 1 0 is a number in the base 3. Right? Now you have to add 3 plus manuand. 3 minus 1 is 2. Now here is a 1 borrow. 1 borrow. Here is there. So this borrow is there. 1 borrow is there. Okay. So here is again 0 is less than 2. Here is 3. This value is basically in decimal is 3. This value is in decimal 3. So 1 borrow, you will get a base value. When you are getting a borrow, you will get a base value. Either you represent in that base because we are performing the operation in that base, or you can represent in the decimal in your brain, and then you can do the decimal subtraction. Okay, 3 minus 0, 3 plus 0 minus 2, 1, and 1 borrow is there. So here is again 3. 3 plus 1 minus 2, 2. So this is there. But in computers, so how you are adding this, it becomes a 3 operands. And if you think about your arithmetic logic unit, you are having only 2 operands to operate at a time. So this subtraction procedure is not a valid. Then we go for another method that is known as a complement method. So we will discuss later on. So we can say here when manuand is larger than or equivalent to subtrahend, then there will be no borrow. When manuand is smaller than the subtrahend, then there is need of borrow. Borrow is taken from the next higher place value digit as base R value. Now you are representing in decimal number or in your that same base. Be careful here. Borrow is added to the manuand and sum is obtained. Subtrahend is subtracted from the partial sum to get the difference. So this is the procedure. Here, if I am considering here decimal number, the same is there. 6 is lesser than 7, so there is need of the borrow. If I am taking a borrow here, so it is in the base 10. So 10 plus 6, 16, minus 7, 9. So you will get here minus 2 plus 2. Here is 1 and 1 minus 1, because you are going to subtract here. 1 minus 1 is 0. Okay, so this is the, here is decimal. So 2 and 2 both are same value, no need of borrow. Same value, no need of borrow. This is larger than 1, no need of borrow. 2 minus 1 is 1. Here in base 5, 1 minus 2. 1 is less than 2, so there is need of the borrow. When there is need of the borrow, so you will get here 1 0. 1 0 means 5. 1 0 means 5. 5 plus 1, 6 minus 2, 4. Okay, so now here is minus 1 plus 0, minus 1 and minus 3. Or you can say this is lesser than, again. There is need of another borrow. So you will get 10. 10 minus 1. 10 minus 1 means here is 5. 10 is not. It is not a decimal value. It is a base value, 5 value. So basically it is a 5 value. If you are representing base and you are writing here 1 0, it means it is 5 in decimal. So 5 minus 1, 4 plus 0, 4 minus 3, 1. So 1 borrow is there. 1 and 1 will cancel out and you will get 0. So if here is a base 7, so 5 is larger than 3, it is 2. 3 is larger than 2, it is 1. So you will get here. So when you are subtracting, you will always get a number which is a base value. But when you are adding the two numbers, you will get a number which may or may not lie in that base value. So this is the main concern. So then we go for the complement form. So what is the advantage of the complement form? We are getting a subtraction using the adder. By performing the addition operations, we can get the subtraction. So this is the advantage. So no need of the previous carry, add, that, 3 operations are not required. So complements are used in digital computers to represent the signed numbers, or simplifying the subtraction operation, and to represent the signed numbers. There are 2 types of the complements. There are 2 numbers complements, then those you can represent here. So that is there. So one is R minus 1. This is known as a radix minus 1. Radix minus 1. Radix minus 1. Or it is a complement. So another is R's complement. That is true complement. Either we will say radix minus 1, it means base minus 1 value. True having the same base. R minus 1 complement or R's complement you can get. So here is the number. That number is represented by n. That is a complement number of n number in base R. In base R. So that is equivalent to R power n to the base R power minus m to the base R, and n in the base R. So you will get a number. You will get a number. So what is n? N is the number of integer digits in the number. M is the number of fractional digits in the n number. So where n is your always a positive number, or it is a fractional part, but it should not be a negative number. So all the positive numbers are known as a unsigned numbers. If you are having a positive or a negative sign, then you are saying that is a signed number.